You're welcome to another video. So in this video, we're going to be looking at creating variables in Zig. So basically, we're going to be talking about some of the basic data types in Zig, primitive or fundamental data types that are available in Zig. So in the last video, this was what we had. This is what the Zig build system created for us, so we could delete that. We're also going to delete this test because we're not going to be using it in this video. So we're going to keep this std input, but before we do that, let me actually explain what is going on here. So you can see we have const std. So the std is actually what is responsible for basically the standard library package. So this is your entry point to the standard library. So for example, if you do std dot, you're going to see that you have a bunch of things that you could use here that comes from the standard library. So if you're interested in using all the stuff that the standard library has, which isn't really much right now, but you know it's available and useful for a lot of use cases, then you can find it here. So that's for std, but that's not what we're going into in this video. What we're going to be talking about mainly in this video is going to be fundamental data types. So for example, in Zig provides things like integers, which is for whole numbers. It also has floating points data types, and then it has, so I think that's majorly the fundamental data types that Zig provides. But not just that, we've got structs, we've got enums, we've got unions, and that's mostly what we have. So this is what we're going to be talking about in this video. But then Zig also, interestingly enough, allows to work with types to a degree. Of course, it doesn't really support like fully manipulating types and such like that. So for integers, we actually have the we have signed and unsigned integers. So the signed integers always start with I, and then the suffix for the width or the size of the integers in bytes. So for example, we have 8 bits, I8, which is actually a byte, which is a signed integer of a byte. We also have U8, which is the unsigned version of the I8. We have the I16 and the corresponding U16. Now, this is typical of most programming languages to provide this, right? So we have the I64, U64. Interestingly enough, we also have the 120, I128 and U128. So you might think this is everything that we actually have in Zig, but that's not true. We still have things like, we could even have I1. Why the hell not? So this is provided for us by Zig, and which means if we have I1, maybe we could have I2 and U2. Now we're going to find out if that's really true. So this is everything that Zig provides. So you can see that Zig allows us a great deal of flexibility in whatever we want. So for example, we could even have U5, I5, U5, as data types for integers, which means that you can basically represent most of your data types using the amount of bytes you want. So for example, I believe this is 1 byte, this is 8 bits, 1 byte. So for this U1, this is actually going to be like 1 bit. So if you wanted to represent 1 bit values in your program, then you could do that using in Zig without any issues. So that is that for the integers. And before we get into the other things like actually declaring variables and such, then we're going to talk about some of the floating point values. So as far as I know, we usually only use F32 and F64 floating point data types in Zig. I don't think we have any other like floating point data types available. We just have the F32 and F64. But I might be wrong, and if anybody's watching this video and this is not accurate, please let me know. Now we also have the struct data types. So the struct data types is actually an interesting type in that a struct actually doesn't contain anything. A struct is just a container for all of these data types that I've just underlisted. And I think I forgot one, which is a Boolean type. So it's called bool, and this Boolean type is can actually store values of just true or false. So there's also a bool type in Zig, so you should remember that. Um, so a struct, like I said, actually does not contain any value. It doesn't have a size, for example, as these other values have sizes. I think I also forgot one other integer data type, which is the I size and the U size. So this I size, the size of this I size is actually the size of, a register in a general purpose register in your operating system. So if your operating system is 32 bits, then you're gonna get your I size to be 32 bits, and your U size to be 32 bits or 64-bit, depending on the architecture of your system. So once we have that, now I was talking about structs not having a size of its own. So the size of a struct is actually the size of, the members that are stored inside of the struct. So for example, I could have a struct that stores, um, an age. Now, if the age is I32, then the size of my struct is actually going to be I32. Is actually going to be the size of I32. And the size of an I32 is actually 4 bytes, so which means the size of my struct is going to be 4 bytes. We're going to be investigating and looking a little bit more in depth into this, and you're going to understand. And the reason why I'm going to be emphasizing a lot on the size of a struct is because I want to show you guys a bunch of really cool things you can do while working with struct and zig, and how to avoid, how to actually achieve a lot of zero overhead and stuff like that. Basically, extending types in zig. We're going to look a little bit more into that in subsequent videos. So we have the enum types, which is just enumeration of values. It's basically usually integer types, but you could make your enums. Um, so you could make your enums actually have some specific values. So for example, we are going to look at how enums are basically declared, but it's basically enumerating values of a particular type. So yeah, that's all I can tell you about enums for now. Now unions is actually an interesting case. If you come from C, then you understand what unions are. Unions allow you to store multiple types inside of it, and then only one type can be active at a time. So for example, I could have a union of like 3 to 4 different types, and then depending on the logic that I have in my program, I could set one of those types inside of the union. So that is really cool. Zig also has something called tagged unions, which if you've used Rust looks more similar to the enum type in Rust, which is really cool. Yeah, so the last one here is actually type, which is interesting. So in Zig, you can actually deal with all of the types of this, um, and actually work with them in some context, which is basically mostly is usually compile time. Just compile time based stuff is what you can do with this type. So that is everything. So let's just show some examples of how you're going to work with this. And before we do that, we also have to get into the concept of variables. So what are variables? Variables is actually how you store temporary data inside of your program. So for example, I might want to store something like a user's age, for example. So if I want to store the age, I have to create the variable and then allocate some memory on the stack to be able to do that. And the way you declare variables in Zig is with the var keyword. Okay, so var age, which is the name I want to use to identify the variable, and now we need to know the type of the variable. So in this case, I want to use U32 unsigned 32-bit integers because age is going to be a non-negative value. So the only time you use signed values is when you have negative values. So we have unsigned 32-bit integers here, and I'm going to say 10, for example. So now we have the age to be 10. And this is how you declare a variable in Zig. So you have the var keyword, you have the name, which is the identifier for the variable, you have the type, and then you have the value. Now, most of the time, you can actually leave out this, but trust me, Zig's type inference isn't really good enough to be able to detect this. So I recommend that most of the time you actually specify the type of your variable when you declare that. It's really, really useful for, you know, for Zig to be able to, for example, because if you leave out this type, now Zig is not going to know what type you're actually talking about when you declare a variable like this. So we have the age, and this is how you declare variables. Now, storing types like this inside of the temporary storage like this actually is two types. So we have variables and constants. So variables, the value can change later. For example, I could say age is 30 later, and then I could do the print, and then I could do something like age. So this is how you print. We're going to go a little bit more into printing and stuff like that, but just let it go for now. So you can see that if I created age and I assigned the value of 10 to it, and then I'm reassigning the value later. And so if I go back to the terminal and I try to run this program, you see that the program is going to work without issues. Hopefully, if I don't have any syntax error, you can see we have 30 just like that. Now I need to put a new line here. So that is that, right? Now the next thing we need to look at is going to be constants, like I was saying. So if I change this var to a const, you're gonna find out that I'm gonna get an error in the compiler. So you can see, if you notice, you're gonna see that we don't have any errors. We don't have any errors in the IDE, and that's because there's a lot of missing features in the LSP for now. So you're not gonna get some errors that you normally get from most IDEs for most languages. But if you try to run this, you're gonna see that we get the error here, which is on line 15 cannot assign to constant. And if you go back, you're gonna see that line 15 here, we're trying to assign to what is called a const, and that isn't gonna work. So if you want variable storage, then you gotta get that from here, right? So this is everything you need to know about declaring variables and such like that. So this is how you're going to declare integers, for example, and you can do that with age. We also have the Boolean types. So now, like I said, we know that this is stored as a U32, right? And if you want to check the size, just to confirm that I'm telling the truth that this is going to be 4 bytes, then you're going to have to do size of age, for example, and then we use what is called this is called string interpolation in most languages. And so this is basically what Zig also do, Zig interpolation, but there's actually a little bit more detail to that, which we're going to get into later. So size of age, and this is what is called a built-in. So a built-in has this @ symbol in front of it, and then we have the identifier, or whatever you want to call it. So this built-in is actually something that is provided as a built-in by the Zig programming language. So it's like a function that you can call to perform something, and you're sure that it's always available for you to use in your program. And so that is the built-in. And now if we run this program again, hopefully we don't have any issue. Right, so this is actually saying that it requires a type. So we could do type of, to get the type of age. And now once we save that and we go back, we could run the program, and hopefully we're going to get good results. Right, and you can see that the size of age is 4, which means that this is actually U32 is actually 4 bytes. But the interesting thing is we could actually check for the size of other values. So for example, I told you that we had U1. So just to confirm that this is actually true, if we check now, we should find that U1 is actually 1 byte, just like that. And just as we had U1, we could do U3, for example, and this is still gonna work because this is actually a valid type in Zig. So you can see this is U3, right? Why do I have 1 byte for U3? Well, that's interesting. So what about a U5? Well, I'm still getting 1 here. I hope I'm not doing something wrong. U14. Okay, this is 2. So I have absolutely no idea how these things are represented in memory, but apparently for some values you're gonna get them, but the way they're stored in memory is not going to affect how, I believe, shouldn't affect how those values are stored. Of course, the layout, the way you store the memory is going to be aligned to 8 bytes. So I believe that is what is happening with the other values. But yeah, that should work. Anyway, so this is how you're gonna declare integers, and we have booleans. So booleans actually, um, you know, is old. You could do bool like that. Sorry, to actually declare variables and follow best practices in Zig, we use the snake case. So you could do true, you could do false. So this is valid construct in Zig for writing Boolean variables. Of course, you could also declare constants like this, and of course, um, we could also have floating point values, which is values that has decimal values, decimal points. Let's actually write pi, f64 whatever, and then we could have 415 whatever. And now we get into struct. So struct, I said a struct is actually something that, so I'm going to say user, and I'm going to declare struct. So this is how you declare a struct in Zig. So you can see that a struct actually looks like something that you're going to declare with other values like this. Now you cannot declare a struct with var keyword. This is not going to work. All right. And also you have to use the values, the variables you declare in Zig, or else the compiler is going to complain. So you can see I just have this is old variable here, and I haven't actually used it in my program. So if I do Zig build run, you're going to see that I have unused local variable, and here we also have an unused local variable. So you have to use the values, and if you don't want to use them, then use this underscore to tell Zig that you're actually aware that this value is not used anywhere. And so you can see we have this, so I believe, so we have this struct, user struct. So I'm declaring this with var to see if this is actually going to compile, and it looks like it's compiling. So we see unused local variable. So let's see what can we do inside of this user struct. So I'm going to put some age, which is going to be an I32. So I was saying something about this becoming 4 bytes because the size of a struct is just the size of its members, right? So if I do std.debug.print and I say size of user is going to be, oh yeah, so size of user is going to be size of user, and I save that. I need to clean this up a little bit. Right, and I think I need to enable the document formatter, and to do that I have to use the command shift P and say format document. So yes, it's going to ask for a default formatter, and I'm going to use the one in this one from the Zig language server, so that I can actually format. I believe I should be able to format the document now, right? Yeah, this works. So I think I need to enable the auto formatting of the thing inside of the settings, but I'll do that later. So right now you can see that, so I want to print the size of this user. Let's see if we can do that. And as you can see, it's complaining that variable of type must be const or comp time. So this is what I was trying to explain earlier. If you're declaring something like a struct type or whatever, you have to declare it as const, because Zig doesn't allow you to modify some of the types of these things. So once you do that, the error should go away and you should be able to run your project in peace. So you can see the size of user is 4. The percent sign inside, you can see there is because I don't have a new line here. So if I add a new line and we go back and run this again, you're gonna see the same thing we had before, and you can see size of user is 4. So you can see that this means that a struct is only, the size of a struct is only the size of whatever we have. And to show you guys what I'm trying to say, we could do composition here and say user is going to be a user just like that. And what that means is that if we look at the size of user 2, it's still going to be 4. And why is that? This is because this user two does not allocate more memory than what user is. So the only thing that allocates memory is actually all these primitive values that we have in our program. So this means, so I'm saying that the size of user two, even though it contains a user that actually contains an integer, is going to be 4 bytes. So let's see if that is true, and if we run the program, hopefully we should get 4 bytes. Yep, we get 4 bytes. So this means that you can actually perform composition pretty easily in Zig. So if you have a type, for example, that you want to extend, all you have to do is take that type, as long as the type is actually, you know, the 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 members of the type is publicly available, and I think every member types in Zig actually have the, you know, publicly available type. So you can actually just extend that particular type, and as a member of the variable, and then you can extend it and write whatever functionality you want on top of that. Anyway, that is that for structs. Now, that is actually not that for struct, because there's more things that can be contained inside of a struct. So struct can have member functions. You could also have you could also have like just static functions. So it's not particularly static, but it's tied to the user namespace, which is the type here. We're going to be taking a look at this when we look up at structs in depth in a future video. So just know that we can actually have namespace or member functions inside of our structs. So yes, that is that about the structs, and yeah, I think I could leave that. I can leave that here, right? And we also have enum. So how are enums declared? I already told you about enums. The same way you declare a struct. So you can say, of course, you could have days. You have months, and we call that enum. And then you could have something like January. You know, January, February, March, and to the end, of course. So you could specify as much as you want for an enum here. And the cool thing about the enum is to declare this, you could do something like month, which is of type months, and then you could do something like January. So this is how you're going to use an enum in Zig. So you can see this is really nice, and we could even print it out. And so we're gonna do month is going to be month, just like that. So if I run this now, you're gonna see that we have an error. Yes, so it says non-exhaustive enum missing integer tag type. And if you notice, you're gonna see that I have this underscore at the end here. Now if I remove this underscore by commenting it out, you're gonna find that if I go back and run this, it should work. And yes, it does. So you can see that the month is January, right? So if I go back and add the exhaustive thing back and non-exhaustive, so the non-exhaustive, this underscore at the end of an enum means that this enum is non-exhaustive, which means that in future versions of this application or library, we can add more values to here, and we just have from January to March, so we still have more months to fill. So this means that this enum is non-exhaustive. Alright, and this is really cool for when you're trying to switch on an enum value. The compiler is going to force you to have a default case for a non-exhaustive enum. So this is how you're going to use your this is how you're going to create enum values. Of course, you could also just write months or January, but that's a little too verbose, so we don't usually do that. You could just type January as we have it here, and we have the month. And also, enums can also contain namespace functions, and it could also have things like member functions which act on a particular enum. We're gonna look at that in subsequent videos when we dedicate a video talking about enums. Now, also, I believe if I run this program, I'm still gonna get an error because there's something that it was talking about missing integer tag type. So we need to fix the integer tag type, and to fix that, we need to specify the type of the enum. So how should the storage type for this enum? So we could do, for example, u8. And once we do this, our program is going to work because we've now specified the type, the tag type for enum, just like that. And now we're going to talk about unions. So like I said, unions are a collection of values that we can store in our program. So let's say, for example, we want to store a user and a month, and month, yes, and a month, and depending on whatever I want to check if I have either one of them set. So in my program, I can either have a user or I can have a month. So user, I cannot type, yes, user or month. So I have a union. What is this? So this is going to be a union of an enum. Why do I have a union of an enum? I'm going to explain that in a minute, but this is what is called a tagged union. All right. So the tagged union is exactly what Rust provides and calls an enum. So just so you know. So for this, we're going to do something like user. So the user is going to be of type user, and month is going to be of type months. Now, how do we create this enum? Very simple. How do we create this union? We just do some user or month. Here is of type user or month, and we're gonna say user or month to make sure that we assign a value to it. And now we want to do dot user because we want to initialize a user, right? So this is how we initialize a struct. I believe I showed you how to initialize a struct. Oh, I didn't do that. So this is how you're going to initialize a struct here. Dot age is 20, for example. And now the only field that is set in this user amount is the user. So for example, we could switch on this user or month to determine if we have a dot user. You don't have to understand all of this because this is just a high level overview of some of the types that are available in Zig. We're going to be going in depth on all of this in subsequent videos, so you don't have to worry. But now what we could do is do std.log.info user, and this should print if we don't have any compile errors. Should print the user. So we have a compile error, and yeah, we're supposed to have u because this is the capture type we have here. Also, like I said, we're going to be talking about capture types in later videos. And yeah, so we did not handle month, so we could use like a catch-all thing to make sure that we handle that. And the reason why I'm not handling the month is because I know that this doesn't actually contain a month. So you can see that here we have the month, I believe. I think I need to put a new line somewhere here. So once I run this, you're going to see that we now have our user with our age 20 from the union here. So I already talked about types as being first class values or whatever in Zig. You can see month, so you can see the way we declare types here as values. There is limits to what we can do with them, of course. We can usually only manipulate them at compile time. So yeah, anyway, this video is gone on long enough. Thank you guys for watching. I hope you enjoyed this video. In the next video, we're going to be talking about structs. We're going to be talking about, actually, we're not going to talk about structs. We should talk about functions first. So we're going to be talking about functions in the next video and return types and stuff like that. If you enjoyed this video, make sure you leave a like, subscribe, turn on the notifications, and I will see you guys in the next video.